Welcome, students, to Module 6.2.2, Human Population Growth. As we can see, can you find me in this picture? Can you find Waldo? Oh, there's Waldo right down there in the bottom middle. You see him? So we're going to apply some of the principles that we learned in the earlier module to the human population, which is, of course, a matter of great concern. So every second, 5 babies were born and 2 people died. This means that the world's population grew by 3. The same thing happens each and every second. So this year, the human race will increase by 78 million people. It happens every second. 3 more, 3 more, 3 more, 3 more. And this is something that's important to recognize in our contemplation of human population and the crowding and the impacts that we have. So let's just look. This is, in a mathematical sense, human population change. That little pyramid thing is a delta, so that stands for change. So population change equals the number of births, which is B, plus the number of people that immigrate in, minus the number of deaths, plus the number of people that immigrate out. Now, on a global scale, no one's immigrating in, and very few are immigrating out. So it's really births minus deaths for the global human population calculation. Now, another thing that I'd like you to take into account is that the current situation is unprecedented. It's not the same as it ever was. It's different. We've never had this many people on the planet. This graph shows years before the present on the horizontal axis, and it shows human population on the vertical axis. And it goes back to 10,000, 500,000 would be broken, but the fact of the matter is that for a very long time, tens of thousands of years, essentially our species has been on the planet for around 200,000 years, and since that time, we've had very small population for most of the history of most of human history, and we can see that it is only in the last few years, here's 2000, that's the birth of Christ, and we can see, and there, boom, population takes off. We are right now at 7 billion, and we're still going up in a exponential growth pattern. And this should frighten you. You can see some of the issues or some of the iconic occurrences, the Stone Age, the Bronze Age, Iron Age, Middle Age, and you can see some of the other historical landmarks in this graph. But this is our world. I want you to notice this graph actually spells out in what year we achieved each million. For the whole history of the Earth, it took until around the year 1800 to achieve 1 billion people. And then it just took us until 1930 to get their 2nd billion, so 130 more years. And then it just took us 30 years to get our 3rd billion. And then it took us 15 years to get our 4th billion. And then it took us 12 years to get our 5th billion. And our 6th billion was around 2000, and 2011 to our 7th billion. And so this is an issue that we're going to have to come to grips with. We have one world, and all of us fit on it. And there are more of us than ever before, and we're impacting the natural world as never before. This is the same data in kind of a table that I just presented to you. Originally, humans were hunter-gatherers. About 10,000 years ago or so, that up until 10,000 years ago, that was true. The global population was 5 million. Of course, now it's 7 billion. And there were 2 big changes in resource use that we transitioned into from 10,000 years ago. The first was agriculture, and that started more or less around 10,000 years ago, more intensively a little bit more recently, and in kind of a scattered way further back. But look at the impacts of agriculture. Of course, habitat destruction. We had to cut down a forest to plant a field in forested areas, or plow under grasslands in grassland areas. And that wasn't a big deal when there weren't very many of us. Soil erosion resulted from plowing. We disturb the vegetation which held the soil in place. And soil is a renewable resource if we don't lose it too quickly. We're right now losing it more quickly than it's being formed by a significant amount. That should concern you because we get our food from agriculture, and without soil, we can't grow food. Of course, the result of agriculture initially was a few people could feed everyone. And so this allowed the population to increase. We had a steady source of food, but we also had a division of labor. This allowed some people to specialize, to become artisans or craftsmen. Some people pursued knowledge, and this was education and science. And so agriculture directly gave rise to some of the big innovations that we saw in human culture. Another result, and not an altogether positive one, is diet or food simplification. As hunter-gatherers, we ate thousands of different species. Now we primarily eat around 50, and most human calories are obtained from just a handful from these 4 species, from wheat, rice, corn, and potatoes. So the second big change in resource use was industry. We can trace its origins back to as far as 200 years ago, but it was only around 200 years ago where it really took off. And of course, that began the rapid use of non-renewable resources, minerals, and especially fossil fuels. It also increased the use of renewable resources, things like forests and water, other wildlife resources as well. It led to further population increase. It increased the standard of living, so we lived better than we had before. It also created pollution. Now, again, when industry was practiced on a modest scale, that wasn't such a big deal, but now there are so many of us, billions of us, then the pollution becomes an issue. This also led to urbanization, people living in cities, and it led to technology, science applied to solve a particular problem. And of course, what our focus here is not some of these other things that we can learn about in history or anthropology, but we're here to learn about human population. So here's a way to depict 2 populations growing at different rates. The one at the left is growing very rapidly. The one at the right is growing much slower. You can see that there are 3 age classes. The orange is the oldest, the yellow is kind of medium, and the yellow is the youngest. It's the yellow that's reproductive. The orange is post-reproductive, and the blue is pre-reproductive. And you can see that in a rapidly growing population that the young make up a very wide base for the pyramid, and it's not as wide in a more slowly growing population. Can you envision then what a population that wasn't growing would look like? Its sides would be pretty much parallel until you got up to the very tip, and then it would go in as the oldest age group senesced and died. And a negatively growing population would have a narrower base than the top, and so that would be a shrinking population. Now, the current population level is not maintainable without agriculture and industry. I've stated before what the current human population is, but you should know it's 7 billion people. And that was just achieved on Halloween of this year, somewhere around there. And the thing is that if the entire population of the earth wanted to live the American lifestyle, well, we're already overpopulated. It would require 3 Earths worth of resources for 7 billion people to live like Americans live. We don't have 3 Earths. We have 1 Earth. And so that is a serious problem, and it is a problem which will permeate all the issues of your time here. And so a critically important population statistic is that about 30% of the people on the planet, and that's about a third, in the year 2004, were kids under 15 years of age. And these 1.9 billion kids are going to be moving into prime reproductive years, and what are they going to want? They're going to want what everybody wants. They're going to want a job. They're going to want a house. And more, they're going to be wanting what Americans want. They're going to be wanting a car. They're going to be wanting a television. And, of course, this leads us to the concept of the ecological footprint. This is the environmental impact of a person or of a population. It can be defined as the amount of biologically productive land and water for raw materials and to dispose or recycle waste for that person or for that population. And we are just using much more of the planet's resources than are available on a sustainable basis. Recall that sustainable means the ability to do it again and again. Here are some ecological footprints. If we look on a per person, that's what per capita means, a per person ecological footprint, these are the number of hectares of land per person. In the United States, we have by far the largest ecological footprint. A European footprint, and Europeans live a pretty advanced lifestyle. There it is. And then in India, it requires very little for the way that most Indians live. They live a very modest lifestyle compared to an American lifestyle. We can also look at not only the impact per person, but we can look at the total ecological footprint. And then we can see the Netherlands really shrinks down because they have a very small population, a modest ecological footprint. The United States has a huge ecological footprint and a pretty large population. India has a huge population, but a relatively a very small ecological footprint per person. And so we can see all these different calculations. And this should concern you. In addition to knowing the global population, you should know the population of the three most populous countries. And these are actually a little old. I have world population as 6.8. It's really 7 billion. China has a stabilizing population of about 1.3 billion. India has a growing population that's just at 1 billion, and definitely India well past China. And the United States is the most populous of the developed countries, has 300 million. So it's the largest and fastest growing population of all the developed countries. And we can look at a projection. We can look ahead, looking to 2050. And a modest estimate is to say that we'll have 9 billion. That's only 2 billion more. They're saying plus or minus 2.5 billion from 2004, and now we're at 2011. It looks like it might be a little bit higher than 9, honestly, but we'll see. You can see we have high, medium, and low estimates, and these are based on different types of fertility rates. So we're not going to discuss here, but it's good to look forward, look ahead, and see what we're facing. Even if all the people on the world on the earth right now started practicing replacement level reproduction, which means about 2 children per couple, a little bit more than that because of infant mortality, it would still take a number of generations for population growth to stop. It has its own inertia. So here's some questions to contemplate. Will exponential growth continue indefinitely? Well, I think we know that it cannot. We have a finite system. How will population distribution change with time? Well, the undeveloped countries will gain population, while the developed countries will be stable or shrink in population. How many people can the Earth hold? Well, it depends. What's the Earth's carrying capacity for what's the carrying capacity for Earth? It depends. At what standard of living? That's the question. How do we want to live? The more of us there are, the more seriously we have to ask those questions. The rate of growth of world population for humans has decreased from 2.2% in 1963 to 1.25% in 2004. In 1963, we added 69 million people with a greater rate of growth. But in 2004, because the base population was larger, even at the lower 1.25% growth rate, we added more people, about 80 million people. So it's good news, bad news. Good news, the truck heading toward you has slowed. Bad news, there's still a truck heading toward you, and that truck is human population growth. Now, human population growth embodies a threat to the ecosystems of the Earth. Now, from a purely human-centered viewpoint, forget about hugging trees or other species. we need to preserve those ecosystems to preserve the systems that humans depend upon. Human population growth is at the root of some of our most serious environmental problems. And I want you to really understand that it's not ethical or moral to let nature take its course with humans. We need to voluntarily limit the number of children we have. And sometimes I hear Americans get very mad at, for example, a woman who lives in Kenya in Africa that has 8 or 10 children. They say, why does she have so many children? But if you look at the ecological footprint, one American child can be equal to 20 or 30 Kenyan children in terms of the ecological footprint. So that's something to think about as well. It's not only how many children you have, it's how many resources those children use. And with that, we will conclude this module, and we'll now look at one aspect of the Earth that is being impacted by this huge increase in one species, Homo sapiens, our species, humans.